good afternoon once again to all the ladies and gentlemen present here. So we have 3 sessions more left. So it's time for us to welcome on stage Professor Ayon Chatterjee, member of the Board of Governors from NIT Meghalaya. Let's welcome him on stage as he is going to be talking about channeling human creativity, conventional research at the crossroads of AI. So let's welcome the gentleman with a big round of applause, and let's have the professor on stage, please.
Good afternoon, everyone. I know it's a very difficult job to give a presentation right after lunch. So what I thought is, let's delete all the data, all the scribblings, and let me tell a story. Because I've been, apart from whatever you have seen on the screen in my introduction, I'm a hardcore researcher. 25 years or so, I have been doing a lot of research, and that too in physics. So, you can definitely call me a mad scientist. And when I think of research these days, challenging human creativity, that I have selected as my topic. And, the conventional research, and we are at crossroads with AI, because I'm like the gentleman out here. I'm thinking, this road, the two roads, one is AI and the other is my research. Are the two roads converging or they are diverging? And I'm thinking a lot about it, and I end up becoming an AI. And now this AI means absolutely insane. Now, I want to begin my entire thing with a small folk tale. Indian folk tale, and it's replicated all over the world also, I've found. The woodcutter and the axe. So there was an honest woodcutter, poor one, and one day while returning from the jungle, he dropped the axe in some deep lake, and then there was a spirit of the lake who saw the woodcutter crying, and then he came out with a silver axe. The woodcutter said, no, that's not mine. So he came out with a golden axe. He said, no, that's not mine. And then he came out with the original axe. And he said, yes, that's mine. The spirit was very happy. He rewarded the woodcutter with all the 3 axes. Morally, a very strong story about honesty. Take it to the realm of AI, and let's rewind the story. Let's think that the well or the lake is my AI that I don't know. And we have an interface, the spirit, which is something like a chat GPT or a Gemini or a Copilot or whatever. A generic AI, that I don't know anything about. So what it has done, that X may have been my research. I have defined, designed the best X that I could make. I have found the right alloy of iron to make that X, the right wood that I have taken. Okay. And what does this AI guy do? The spirit. The design of the X is replicated in no time. It is replicated in a much better material, gold or silver, and you have no idea how was it replicated. So that is what is going inside my mind as I get and welcome to this world of AI. Now, let's again get back to this system. As I said, the well, or all the algorithms and whatever is going on together, I don't know what's happening, where is my data going, what's happening to the data, is it being stolen, it is being stored, I have no idea. And I have an interface, which is, say, ChatGPT. Let's take it for an example. Now, ChatGPT, if you look at these three letters, GPT, generative, pre-trained, and the third word is the transformer. Generative, pre-trained, transformer. Generative, it generates by its own. Pre-trained, every time we get data into the system, it's getting pre-trained. But the transformation is the dangerous part out of it. If you get into the technical part of it, these are linear functional circuits, linearly learning. Okay. Now, what is there in those algorithms are a very large, millions of these transformers. They learn. Say, when we were learning our alphabets, A for apple, B for ball, and C for something, and Z for zebra. Okay, so as the child learns, you show him one picture of the zebra, he has picked it out, and next time he goes to the zoo and he can identify what's a zebra. That is not the case with generative AI. It will take the picture of a zebra, but the stripes are there. It can match with the stripes of your attire or the curtains or anything. And that's why it needs billions and millions of images to learn something. So it is continuously capturing the data that you have. So now let's get back to a research. When I go to my research, there's an idea, there's a background theory, there's a focus, there's relevant information, there are certain tools, and I'll come up with some knowledge or product. Okay. Now let's look at that one by one. How do I get an idea? Idea comes from previous research, from previous theories, and also there's a human imagination element involved there. With the idea, as soon as I have a research idea, I'll try to go into the background theory and search for material. And then, as I have the background theory with me, I try to find what is my focus. So I narrow it down. Okay. And as I narrow it down, I go further. I try to sort out the relevant information. Once I have this information, I decide on the tools, the experiments, the simulations, and all that. And then, yes, I produce knowledge or I produce a product. But having stated all that, I need to also realize that this is not a linear process. I'll go back and forth in each of these steps. And as I go back and forth, what happens is I learn, unlearn, relearn, and the cycle continues. And moreover, it's not only I who is involved in the research, it's a huge community. It's all the team members who are involved, who are the collaborators, there might be funding. So, it becomes a much more complicated process than the linear process that I have shown here. Now, taking that into account, let me ask this question to myself. Can AI help us with research? Yes, in the present scenario, the answer has to be an emphatic yes. Because if I tell no, I become a primate. And so, I need to decide where can it help me? Because that's a very important question to decide. And then I thought, let me explore the net. Let's see what is available about the kind of research that is happening, what happens with the intervention of AI. And that took me back to a very interesting experiment or a case study that happened around 2019, just before the COVID. was done by this fashion group Lacoste along with this garderobe. And what they did was they created so they created something shop the model look. So the customer, without wearing something, you can just put your image in the AI, and that was not a real AI, the primitive AI, I'll say, and you can get the look that you will get by wearing something. Okay, that was fine. They did some more iterations on that, evolved the system a little bit, and they developed something called the style assembly. Okay, in the front end of it, things were very good, but the more interesting thing happened in the back end. Now think of a garment factory with a lot of workers, and we know that when we have a lot of workers together, say 1,000 or 2,000 workers, organizing workers is a very tedious job. Now, inside the factory, what they did was they just replaced the lower and the middle management with algorithmic support. Totally, all the mid-level managers, low-level managers were moved out of the system. Every worker was given a tablet that gave what work was to be done, what information was needed for him. Now, these tablets also described the productivity for the day. And then it was able to segregate what was due to an individual contribution, what was the contribution of the team, and directly, what we call the satisfaction that we get immediately. There is a term for it, I cannot recall right now. Okay, so this tablet gate, every day it updated what's the wage or bonuses that is earned by someone. With that, what happened is, we were in a situation where humans working on machines were told by machines what to do. The result was the workers were very happy with this implementation. And why they were happy and they loved the system is because they did not have to request anyone for favor. Like, if I need a better station of work or I need a particular thing, I put my request in the AI, and the AI would optimize that. They got fair and unbiased allocation of work. They did not have to run after people for replacement of parts or for supplies. They felt empowered by AI management. And they knew the exact contributions, earnings, and bonuses. So now, this was a very, kind of a breakthrough experiment for them. But what happened here, because the case was taken much further, people started looking into it, what's happening. And they came up with a theory which is called the self-determination theory. And there, human beings have three basic needs in any work environment. And these three needs are competence, autonomy, and relatedness. And if these needs are satisfied, you become more engaged in that domain. And this is what people have started calling as intrinsic motivation. Now, this thing, okay, if I go a little bit further, let's just try to understand the competence. That was basically the desire to go better. So in life, whenever we have a work, we try to find out what are the goals. And once you know the goals, we try to find out what are the tasks needed to achieve the goal. In our workplace, strategic objectives are there that are divided into smaller goals, and there are tasks assisted by competence, and we found that AI can play a major role in those kind of situations. If I look at autonomy, that is to feel as humans are in control. So what we need to know is what's happening around us, and we need to have some kind of a transparency. Because as we start talking of AI, these are the two terms, like, are we really in control, or do we have transparency? These are the questions that keep on coming. Okay. But it has been found that in AI, choice is not an issue because options are always present. AI provides extreme transparency because it gives us all the information we require, and information is given in the way we understand. And I can cite an example here. Like as a researcher, as a teacher, or sometimes as a leader, you know, I always say, my doors are always open, please come whenever you want. And this is you know, yeah, we all do that. But in reality, if you see, what happens? Most of the time, I'm not in the office, I'm busy in some meeting, and the person who's approaching, that person is asking, is that a stupid question, or it will harm me in the long run? These are all human tendencies, you see. And with AI, okay, replace the leader with the AI, no such issues. AI has a lot of patience. It explains and listens with a lot of patience. So, no, I'm trying to balance it out, whether AI is winning or losing. Okay. And the third thing is need for relatedness. How do I relate to my work environment? How do I relate to my colleagues? And this human desire to belong is because we want to belong to a group or a collective that has a bigger cause. And what's happening is most people today, we have a feeling of being isolated or disconnected. In here, AI can be taught charismatic and inclusive speech. And if you look at what Google is coming out with, about a month back, the video came out. It's, you know, the AI voices are getting emotions now. AI can be made to speak in a way that makes people feel that they belong to the group. And that's why you will find, I have seen a lot of kids today, they connect more easily to Siri, Alexa, or Cortana compared to, you know, anyone else. And it has been also found that these chatbots are becoming more and more popular as they are more in the Asian context. Okay. So with these things in mind, are we ready? Okay. But as soon as I get back to my, you know, lab, wear my lab coat, I understand that even inside me there's an aversion to changes. And this aversion to changes is a basic human characteristic. And I can give you two examples here. Okay, like motor cars. Today, we ride motor cars, we drive them. It has become a part and parcel of our life. But when Henry Ford invented the motor car, what was the rule? That the horse carts are much better. And that's why when someone was driving a motor car, someone had to be there with a flag so that the horses doesn't get scared. Okay. So that was the rule of that time. Similarly, if you see the travel by railways, because initially railways were used only for goods. In Paris, it was used for the first time for transshipment of human beings. And when that was happening, there was a Victorian theory that a train ride could cause instant insanity. They said that, you know, our brain is made of a gel, and if that gel is riding something at 40, 50 kilometers per hour, maybe the gel will shift backwards and we'll end up with a lot of insanity. So these aversions are there. Okay, we are always, there's a natural aversion to changes. And this is the same change we feel when cell phones came, televisions came, internet came, and the same is coming with AI, as we have that presumption, there's something within us that will AI take over the world? Okay. Now, keeping all that in mind, can we foresee the future? Because AI is a disruptive technology. Okay, it is definitely going to disrupt the way we look at things. Okay. Now, what we see today, say, I'll call them the unstructured AI, ChatGPT and the kind, okay, Gemini or Cortana or whatever it is. There you will find that the disruptions they are creating, recently things went wrong, very wrong with the Ghibli images. We all enjoyed that. But what we need to understand here, the images got captured, the images got modified, the images got cartoonized, and with that, all that happening in seconds, what happened is your faces, your loved ones, everyone's images have gone somewhere. We don't know where it has gone. Okay. But what happens here is AI is something that, we have a lot of limitations. And if we look at the limitations, our strength and endurance, how fast can we run? Usain Bolt can run 100 meters at 36 kilometers per hour, and that too only 100 meters. If you change the distance to 200 meters, maybe the speed will become 32 kilometers per hour. If we start, most of us will end up maximum, say, 25 to 28 kilometers per hour, and that too for short intervals, and will give up. We are aging, and with age, our sensory perception decreases, and our general health deteriorates. We have a lot of time constraints, lifespan is fixed. We have a lot of cognitive limitations, like attention, memory, and other limitations like spatial limitations that we can be at only one place at a time, environmental factors, and facticity. Keeping all that in mind, again, if I revisit AI, okay, there are a lot of great things AI is doing these days. Weather prediction, design generation, translation. The AlphaFold is a very successful work with protein folding. Simulations have become much, much easier in research. Real-time data tracking, almost every one of us is wearing some kind of a tracking device, the Apple Watch or something, because that makes, we are being tracked, we use the data to better ourselves. But there has been big failures of AI. And I would say self-driven cars. We are hearing about self-driven cars for how many? Around 10 to 15 years now. Every car they have made has crashed. It's not happening. So there is a very significant failure here. And mathematics, pure arithmetic. Try it in ChatGPT kind of a thing. It fails badly. Excel sheets are much better. Okay. And why that is happening? Because the processing is much different from the way we process an Excel sheet. So limitations are also becoming visible in AI. Now, why I'm putting it all together is because I'm going back and forth between the research that we do and, the way things are developing. Because research also fails. And why research fails? Most of the time, it's a flawed methodology and design, the planning and execution issues, And, you know, a lot of it, I've put it in this things. External factors and resource constraints, and failure to learn from past mistakes. Okay. Now, classic examples here again I'll take, say, in the Indian context, where we have all these missions coming up. Right now, we have the mission to make a chip, the quantum mission. Okay, and before that, we had the nano mission. Nanoparticles, everyone in India took up this as a challenge. We made a lot of nanoparticles. But what happened to the research? We ended up publishing a lot of papers. But on the ground, has anything been done by Indians? The answer is no. And why? Because, you know, our focus was wrong. We just had a methodology, but we did not think what to be done with that research. So can AI help me there? Of course it can. Okay. So what do I need? Okay. If I am to put my research and I use AI, the first thing I'd be requiring is a very secure platform. I don't need an infinite well like, say, a ChatGPT or a Gemini, where I don't know where I am getting the information or where it is disappearing. So I need something that is very easy to interact, because learning takes a lot of time. We have a lot of time constraints. So can I interact? Okay. I need knowledge of the sources. What is the source of the information I'm getting? Because today, in today's world, a Google search of anything gives you 1 million pages, out of which you will find that 90% of them give repetitive or fake information. Useful, so sorting out the information is very difficult. You, of course, need a comparison tool, a summarization tool, and a tool that provides me further suggestions. And this is where, you know, I really connect with Science Direct AI. Because when I think of research in a very hardcore way, I find that in Science Direct AI, I'm finding this sort of a connection. Because otherwise, I had been very, very apprehensive of AI. I don't use it neither in my research nor in my reviews, because I found it to be very dangerous. My colleagues have shown me that they have used AI to review a paper, and then the paper failed plagiarism check. So somewhere the paper has been stored. And so coming to Science Direct AI, at least some of my concerns, like a secure platform, easy to interact, knowledge of the sources, comparison tool, summarization tool, you know, I get a fulfillment of these goals. Okay. Now, of course, I was looking into these things, okay, as I was using the Science Direct AI, and I got to use, you know, a small demo. So I found that, yes, they are going to help me. Okay. But, you know, I'm not going to give you 100 marks on that. Till now, I can give you 60. Let me use it a bit more, then I can come out with a real critical appreciation of the tool. Okay. But since this, I've directly copied this from your thing. Okay. But, you know, the other thing is, as a researcher, I'm not satisfied. I need more. Okay. And what more do I need is somewhere where I can really collaborate. Because research is not something we do in isolation. I have my team members, I have my collaborators. Can Science Direct AI put all of us together in the platform? If that happens, you know, we have the discussions inside the platform. We have the the whole development of a research inside this platform, it would be great. So with that hope that I'll be getting that in near future, AI will really assist me, and it will take us for research in those things which we have not even thought of. With that, I put my talk to an end. Thank you.
Do we have any questions from the audience? No? Okay.
Okay.
Thank you so much, sir. Thank you.
Very much.
Professor Bhattacharya, this is a very interesting platform and all. Elsevier has got a system. I don't know if the Elsevier team is here. They have got a system called Pure, where basically it works on the research information management system. And in that, where basically a collaborative research takes place. Say, for example, I am working on a disease called lymphosarcoma. So I can easily find out who are the other scientists who are working in the world on lymphosarcoma of different types on that. So that component is Elsevier has got.
Okay. I'll get to know more about it. Thank you for the information. Thank you very much.